January 2019, paper 1HR model solutions. Okay, so the first question is about adding fractions, and we need to show this quite clearly because the answer is given. So one way to do this is to turn both of these fractions into improper fractions as follows. So times, then add. So 3 times 1 is 3, add 2 is 5. Now, there is a way to turn a mixed number into an improper fraction on the calculator. Press Shift and the fraction button so it appears with 3 boxes, then type in mixed number. Press equals and it will turn it into an improper fraction, 11 and 4. We now need a common denominator. We use this method for adding and subtracting fractions. So, 3 and 4 both divide into 12. Okay, I like to write a little arrow here to say what I am multiplying the denominators by. So 3 times 4 is equal to 12, 5 times 4 is 20, 4 times 3 is 12, so 11 times 3 is 33. Add the numerators together, 53 over 12, and then you need to write your answer equals the example's answer. So 4 and 5 twelfths. And if you want to check if it's right, just type in your answer into the calculator. So 53 over 12, press equals, press Shift and the S to D button. You should come up with the right answer. Okay, next question. Okay, so in a club, in the club, the ratio of girls to boys is 3 to 1. So 3/5 of the girls play a musical instrument, 4/5 of the boys play a musical instrument. So I'm just going to deal with this part first. There are 60 children in the club. The ratios add up to 4. There's 4 parts altogether, and these 4 parts are worth 60 children. So what I'm going to do is work out how many girls there are and how many boys there are. So 60 divided by 4 because there's 4 parts altogether, and the children is represented by the 4 parts. 1 part is worth 15. So we need to times both of these numbers by 15, as we have 3 parts here and 1 part here. So 45 to 15. Now, and also this adds up to 60. 3/5 of the girls play a musical instrument. Okay, so 3/5 of is times in maths. 3/5 of 45 is 27. Type that into the calculator, and then 4/5 of the boys, of is times maths, so 4/5 of 15 boys is 12. What fraction of the 60 children play musical instrument? So a fraction of the 60 children, so it's out of 60, and it's what fraction of them. So we have worked out how many children play musical instruments. We have 27 add 12, which gives us 39. So 39 over 60 is fine. If you want to cancel it down to 13 over 20, that's absolutely fine as well. Okay, next question. So work out the length of PQ. Now, the majority of the time when you have 2 right-angled triangles backed onto each other, it usually means that you need to work out the connecting line in between. So, we have to work out QS in order to work out PQ. PQ is over here. We need QS first of all. So if you look at the triangle on the right-hand side, this question doesn't involve any angles at all, but it does involve 2 right-angled triangles, which means it's Pythagoras' theorem only. So, we use Pythagoras' theorem. A squared plus B squared equals C squared. I'm going to work out B. C is always opposite the right angle, and A and B you can interchange. So we have a situation like this. 10 squared plus b squared equals 14 squared. And that means b squared is equal to 14 squared, take 10 squared. That means b is equal to the square root of this. So I'm not going to evaluate it as a decimal. I'm just going to write down root 96. Okay, that's exact. Just write that over here. Root of 96 is this left here. Okay, now I want to work out PQ. To look at the triangle on the right hand side. Okay, again we can label the sides if we wish. A, B, C. So we have 5 squared plus root 96 squared equals x squared. Okay, we can type this into the calculator. Okay, this is 25, and when you square and square roots, they're the opposites of each other, so we end up with 96 there. It's equal to x squared. So 121 is x squared. And then x is equal to the square root of 121, which is 11. Okay, next question. Here are 4 numbers. A is the least number, 40 is the greatest. If A is the least number, and the second number is A as well, that means they're both the same, and 40 is the greatest, which means B is in the correct position, so they are in order of size. The range of the 4 numbers is 14. That means the difference between the highest and the lowest is 14. So 40 take away A is equal to 14. And if you do a bit of rearranging here, 40 minus 14 is equal to A. Okay, so A is 26. So now we know A is 26. Back 26, and that's obviously 26 as well. The median of the 4 numbers is 30. Well, the median is the middle number, and we have 4 numbers here. So if you cross off the 26 with the 40, you're left with 2 middle numbers. So the 2 middle numbers are 26 and B. But it tells us in the question that the median is 30. Now, how do you work out the median when you have 2 middle numbers? Well, it's the middle of the 2 numbers. So they tell us that the median is 30. The 30 must be sandwiched between 26 and B, which means that B must be 34, because if 30 is in the middle and 26 is 4 below, B must be 4 above. So it's 34. Now there is another way of doing this. If you want to work out the middle of 2 numbers, you add the 2 numbers together and divide by 2. So we know that 26 add B divided by 2 is equal to 30. If you rearrange and solve this equation, you're going to do B is 34. It is quite obvious to see. Next. So we have a train that takes 8 minutes and a distance of 30.5 kilometers. Work out the average speed of the train. Give your answer in kilometers per hour. You just need to watch out for this the timing. So what I want to do now is I want to change 8 minutes into hours. You can do that using the time button on the calculator. 0 hours, 8 minutes. What is that in hours? Okay. It's actually 0.13 recurring hours. That's fine. So if I write here, 8 minutes is 0.13 recurring hours. Not very nice, but that's what it is. The formula for speed is equal to speed equals distance divided by time. We're trying to work out speed. So speed is the distance, 30.5, divided by the time in hours, so 0.13 recurring. This is slightly awkward to type in the calculator. So what you do in this case is, because I have converted 8 minutes into hours, and the answer is on the calculator display, I can use the AND button. So if I I typed in like this, 30.5 over, and this gives me a perfect answer of 228.75. Next question. Okay, so this is an isosceles triangle. What do you know about an isosceles triangle? Well, if these two sides are equal, the third side is known as the base, and the base angles in an isosceles triangle are equal. So what we know is 3x plus 10 must equal x plus 52. Okay, a bit of rearranging here. So 3x take x is equal to 52, equate 10. So 2x is 42, and that means x is 21. So now I know x is 21. I know that I can work out the base angles. So if I work out this one, 21 add 52 gives 73. So this angle is 73. Obviously this one's the same, base angles are equal. And then I can work out why. Because angles in a triangle add up to 180 degrees. So 73 add 73 gives us 146. And then 180 minus 146 is 4, 3. So y is 34. Okay. So this next question is to do with comparing heights. So we have two towers here. We also are given information about the scale model of tower A. So let's the tower A model is 90 centimeters. What we're trying to do is work out the height of model B. Now you can relate these two heights together. Okay? As follows. We'll call this one x. Now there's two ways of doing this. We can divide the height of tower A by the height of the model of A, which is 90. We can do the same thing for the other one, because these are scale models and they're related in this way, we can set up these equivalent fractions. So 147 over x. Now this is okay to do this. What I'm going to do is I'm going to write this the other way around. So I have 90 over 187 is equal to x over 147. Now, this may cause some slight confusion, but the model is in meters. The actual tower is in meters, but the model is in centimeters. So this is what we have. This is centimeters. Now, because I've done it in this order, when I work out x, it will work out x in centimeters because it's the same in the other fraction. If you have centimeters over meters, on the other fraction it will also work out centimeters over meters. So I don't need to do any conversions here. I can just simply rearrange this. And the reason I've opted for this version is because the x is in the numerator, and all I need to do to get x on its own now is to multiply the left-hand side by 147, and then I'm left with x on the right-hand side. Okay, so if I type this into the calculator, 90 over 187 multiplied by 147 gives me 70.74, etc. Give your answer correct to the nearest centimeter, 71. Next question. Solve these simultaneous equations. We need the same number of x's or the same number of y's. Okay, we can multiply the second equation by 4, and we end up with the same number of x's. Okay, so just copy down the equations. You have 4x plus 2y equals 9. When you multiply the second equation by 4, you get 4x minus 16y equals 36. Now, when the signs are the same, you subtract. But you may look at these signs and think, well, they're different, but actually you're looking at the wrong signs. Because we chose to make the x's the same, we need to look at the signs of the x's and they're both positive. That's the only way the x's will disappear if you subtract them. So 4x minus 4x cancels, bye-bye. And then, in fact, what I'm going to do is I'm going to write minus in every section so I don't forget. So 4x minus 4x is bye-bye. 2y minus minus 16y is 2y, add 16y, which is 18y. And then 9 take away 36 is negative 27. Okay, so negative 27 divided by 18 gives us negative 1.5. What you need to do now is substitute this negative 1.5 into one of the equations to work out x. So if I use the second one, I have x minus 4 times negative 1.5 equals 9. X plus 6 equals 9. That means x is 9 take away 6, 3. Okay, I would advise that you check this using the simultaneous mode on the calculator. Next question. Write n in standard form. So standard form looks like this: a number times 10 to the power of n. Okay, and this number lies between 1 and 10. So let's divide this by 100. We divide 480 by 100. Result will be 4.8. We've just divided this by 100. That means we need to times the other one by 100. If you times 10 to the power 9 by 100, remember 100 is 10 squared times 10 to the power 9 by 10 to the power 2. When we times we add the power, so it would be 4.8 times 10 to the power 3. Okay, and the next one. Okay, it says write n as a product of its prime factors. Show you're working clearly. So we have a situation. This 480 times 10 to the power 9. What we can do here is we can split this up. 400. Let's have a look. So 480 times 10 to the power 9. Okay. So 480 is 48 times 10. And this is times 10 to the power of 9. If we simplify this a little bit, we end up with 48 times 10 to the power 10. Now 48, let's have a think about what 48 is. 48 can be split up using, let's say 8 and 6. So 8 and 6, so 8 is 2 times 4. 2 is a prime number. 4 is 2 times 2. 6 is 2 times 3. I'll put a circle around all the prime numbers. Okay, so 48 is complete. 48 is 2 to the power 4 times 3. And all I need to do now is work out 10 to the power of 10. Now, remember 10 is 2 times 5. So it's really 2 times 5 to the power of 10. 2 times 5 to the power of 10. Now, this gets a little bit complicated. When you have multiple terms in a bracket that are times together, raised to the power of 10, you raise each of those numbers to the power of 10. So it's going to be times 2 to the power of 10, times 5 to the power of 10. When we combine all of this, okay, we end up with 2 to the power of 14 times 3 times 5 to the power of 10. Now you can check this on the calculator by using the fact button. So if I type in 480 times 10 to the power of 9 plus equals, press shift, and then the fact button. Oh my gosh, it doesn't work. Never mind that. That's the okay. Next question. Find the largest factor of n that is an odd number. The largest factor of n that is an odd number. So you have to pay careful consideration to the actual number, the actual answer to part B, because part B means that you have now written the number in prime factor form. And what we're trying to do is we're trying to find the largest factor that's an odd number. And factor is a number that divides into it. So all of these numbers divide into n. 2 to the power 14 goes into n. But it's not just 2 to the power 14 goes into n. It's like various combinations of this. So like 2 times 3 or 5 squared times 3, etc. Okay? These different combinations, divide into n. And what we're trying to do is find the largest factor of n that's an odd number. So we have two odd numbers here. We have 3 and 5 to the power of 10. 5 to the power of 10 will be an odd number. What we're doing here is we're multiplying two odd numbers together, and the largest odd number that's going to go into n, divide into n, will be 3 times 5 to the power of 10. That's the answer. Next, we have a semicircle here. The diameter of the outer semicircle is 12, and this is fine. Okay, so I'm just going to mark some other information on. The radius of the semicircle is 6 centimeters. Okay, if this outer bit is 2 centimeters, and this is 2 centimeters here, then that means this distance must be 4, which is quite useful. You see. What I want to do is work out the area of the shape, give your answer as a multiple of pi. So what I'm going to do is work out the area of the larger semicircle, which is pi times r squared divided by 2. It's the larger semicircle. Subtract the smaller semicircle, the inner one, pi times 4 squared over 2. Now it's over 2 because it's a semicircle. Pi r squared is the formula for the area of a circle. Obviously, you need the radius, you type it in the calculator. So do not process D. Give your answer as a multiple of pi. Okay, so a combined mean question. 12 boys and 8 girls in a class. The boys and girls have some coins. The mean number of coins that boys have is 55, right? So we have boys and girls, and then we have boys and girls. So 12 boys, 8 girls, we have the mean. So the mean is 5.5. The girls have a total of 18 points. I'll write down. So 12 boys, 8 girls, that means there's 20 students or children in the class. Now, there's one other bit of information that I worked out, which is the number of coins. And the girls have a total of 18 coins. Now, let's think about this. We're just not talking about the value of the coins, we're talking about the number of coins. And it's all to do with the mean. If you want to work out the mean, you add up how many coins the boys have and divide it by how many boys there are. So we add up the total number of coins, then we divide it by how many boys there are, 12. This gives us the average number of coins per boy, which happens to be 5.5. So we can work out the number of coins by multiplying 12 by 5.5. So 12 times 5.5. 12 times 5.5. 66. That means there must be 60. The boys must have 66 coins between them. Okay, now we do something similar for the girls, a fraction. We have 8 girls, but we have 18 coins. There is a total of 18 coins. Now we can work out the mean number of points for the girls. If we wanted to, we'd set it up like this: 18 divided by 8. That's if we want to, just to complete the table. So the girls have 2.25 points on average. The question is really work out the mean number of points that the children have. And to work out the mean number of points the children have, you need to know the total number of points in the first place, which would be 84. 66 from the boys, 18 from the girls. Now, as you can see, this number I worked out here, I was able to work it out, but it's not actually relevant to the question, because I'm working out the mean number of points that 20 children have. And to do that, I need to look at this column, the boys and girls, and know how many coins there are altogether, and how many children there are altogether. So there are 84 coins altogether, 20 children altogether. And we divide 84 by 20. This gives us an answer of 4.2. Next question. Okay, so what we need to explore with this question is the position number. So n is the position number. So this is position 1, position 2, 3, 4, and so on. Now let's have a look at this. What do you notice about the top number of the fraction? The numerator. The numerator is always the same as the position number. So if we're in position n, so if we're in the 5th position, the numerator will be 5, and so on. So if you're in position n, the numerator is n. Okay, great. But what about the denominator? How is the denominator related to the numerator? Well, this goes up in 2s, 1, 3, 5, 7, etc. So it goes up in 2s. So that means if we're working out the nth term for a sequence like this, well, the formula starts off 2n because it's going up in 2s. With this formula for the nth term, we write down what it's going up in as a coefficient of n, and then the term before the first term. So if it starts at 1 but it's going up in 2s, the term before the first one will be -1. So the answer to the question is n over 2n minus 1. You mustn't try to cancel this or do anything else. That's fine. That's the answer. N over 2n minus 1. Using algebra, prove that when the square of any odd number divided by 4, the remainder is 1. Okay. So let's have a look at this with numbers. The square of any odd number. So let's take an odd number, 5, square root 25. Then divided by 4. So 25 divided by 4 is, how many 4s are in 25? It's 4. No, 6. 6 4s in 24. 6 4s are 24. And 1 left over. So 6 and 1 40. So it's basically 6 4s in 25 with the remainder. Okay, that's fine. So we know that it works. I've shown it for an example with a number, but now I need to prove it using algebra. So this is proof the square of any odd number, and our odd number in algebra is either 2n plus 1, 2n minus 1, something like that. So if I use 2n minus 1 as my odd number, then I need to square it, so it's 2n minus 1 squared. When I have a bracket squared, that means I need to multiply a bracket by a bracket. So 2n minus 1 times 2n minus 1, that gives 4n squared minus 2n minus 2n plus 1. When I simplify, I get 4n squared minus 4n plus 1. Now, I need to show that when it's divided by 4, the remainder is 1. Now, this remainder is 1. That's the bit at the end. So you have 4. If you can factorize a 4 from the first two terms, like this. And what this does, they're representing it like this, it shows that when the number is divided by 4, so 4 will go into it, as we can see here, the remainder is 1. There's a 1 left at the end there, and that's absolutely fine. It's fine to leave it like this. Okay. It's showing part of it is a multiple of 4. 4 goes into it, and there's a remainder of 1. That's fine. Next, calculus. Very beautiful. Okay then, so the rule is this. If you have y equals ax to the power of n, dy by dx is equal to an, an and then x to the power of n minus 1. So you multiply the index by the coefficient, and you reduce the index by 1. So 3, so for dy by dx we have 3x squared minus 2x. With this one there's a secret one though. So 1 times negative 8 is negative 8. Then it becomes x to the power 0. Well, of course we don't write x to the power 0. If x to the power 0 is 1, so it's 8 times 1, so we don't need to write it. And any numbers, they disappear. That's because it's the gradient of 12. That's just 0. So we leave it like this. The curve has 2 turning points. Turning points occur when dy by dx equals 0. That's a fact. Turning points occur when dy by dx equals 0. So set this equal to 0, and now we need to solve this and show you're working clearly. So you can use the quadratic formula if you like. Quadratic formula is x equals minus b plus or minus the square root b squared minus 4ac all over 2a. So you're going to write that down. A equals 3, b equals negative 2, c equals negative 8. Start to substitute into the formula. X equals minus b plus minus square root of b squared minus 4 times a times c all over 2a. Okay, and we end up with negative 4, 3, and 2. This is working out the x coordinates, so we can just write them down. Don't need to write down y coordinates as well. But x equals negative 4 over 3, or x equals 2. That's fine. Okay. Show that the x-axis is a tangent to the curve at C. The x-axis is a tangent to the curve. Okay. The curve C has 2 turning points. So when it says tangent to the curve C, what it means is, okay, so with this question, we need to show that the x-axis is a tangent to the curve at C. Now, if we plot this graph on the graphics calculator, we can see that it looks like this. Now, apparently, the x-axis is a tangent to the curve C. There's the x-axis. It's a tangent to the curve. Now we can see that it's a tangent to the curve. A tangent is a straight line that touches the curve at one particular point. There's one point of contact there where it touches. So out of our 2 turning points that we worked out, we can see that actually the x-axis is a tangent at the point when x is equal to 2. This is the turning point that we need to show. And the way that we demonstrate this is by substituting 2 into the equation of the curve to work out the y coordinate. So if we work out the y coordinate when x is equal to 2, so y is equal to 2 cubed minus 2 squared minus 8 times 2 plus 12. We end up with, if we work this out, y is equal to 0. Now, how does this demonstrate it? Well, if you think about it, the point 2, 0 is on the x-axis. 2, 0 lies on the x-axis and is a turning point. Okay, it lies on the x-axis and is a turning point. So that means the x-axis will be a tangent to the curve at that particular point. That's enough to score 2 marks. Next question. We have a cumulative frequency curve. Just got to watch out for this bit here as well. Okay, find an estimate for the number of these apartments with a value of €80,000 or less. So find €80,000. Draw a line up like this and across. Okay, now read off the value. So it's rough. Each square is going up in 2s, so we're looking for around about 96 or 97, somewhere around about there. The mark scheme allows 96 to 98. Right now 97. Next one. On the grid opposite, draw a cumulative frequency diagram for this information. So remember, cumulative frequency is plotted at the end points. So 20, 0. Each square is worth 2, remember. That's fine. Right, now, when you join your points up, it needs to be a smooth freehand curve. So let's have a go at this then. Okay, so something like this kind of shape, roughly. Next. Find an estimate for the increase in the median value for these apartments from 2015 to 2018. So we've just plotted 2018. Okay, so the first one was 2015, this one is 2018, and the median. So there are 120 apartments. That means the median is the 60th apartment. So we draw a line across at 60. To read off the median in 2015 and the median in 2018. So 2015 median it's about 55, I would say. And 2018 median about 68-ish. Okay, so then the difference 68 minus 55, it's about 13,000 euros thereabouts. Next, simplify. So 3, we type into the calculator 3 to the power of 4. 3 to the power of 4 is 81. When we have algebra to powers in a bracket like this, we multiply the powers. So 2 times 4 is 8. Y to the power 20. The next one, okay, we're not used to seeing a situation like this, so what we do is we just multiply out the brackets first of all, and we'll deal with the 4n afterwards. So if we multiply out the two brackets, we end up with n squared plus 5n, take away 3n, then plus 5, take away 3 is plus 2n, and then take away 15. Then we times it all by 4n. So 4n cubed plus 8n squared minus 60n. Next one. This is the difference of two squares. There's a difference there, and they're both squares. You have to spot that 4c squared is the square of 2c, and 9d squared is the square of 3d. When you spot this, it's very easy to factorise it into 2c plus 3d and 2c minus 3d. And the last one, simplified fully. We use the technique, we factorise and then we cancel. So on the top, this is the AM method, numbers that add to make -7, but multiply to make +12. So x and x, they add to make -7, and then multiply to make +12, so -4, -3. The denominator, there's an x that's common, we can factorise that, and when we factorise it, we end up with 4 minus x. X brackets 4 minus x. Now, there is a way to cancel the 4 minus x bracket with the x minus 4 bracket. But we need to make them look the same first of all. So the way that we deal with this is we need to change the signs in this bracket. Okay? Now if we do that, we can do that. I'll show you on the side here how to do this. So we have, at the moment, we have an x minus 4 in the numerator. If we change it to 4 minus x, what do I need to write outside of the bracket to expand it by? So it's the same as x minus 4. If you think about it, it's just -1, isn't it? Because -1 times 4 gives you -4. -1 times -x gives you positive x. We don't need to write it as -1 times 4 minus x. We can just write a negative and 4 minus x. That's the same thing. So what I'm going to do now is change the bracket in the numerator to negative brackets 4 minus x. And we have x minus 3 over x brackets 4 minus x. Now 4 minus x is going to cancel, and you're left with a negative brackets x minus 3 over x. Now what you can do also here is you can apply the negative to this bracket, because one of the terms in the bracket is negative. So if we apply the negative to the x, we end up with negative x. If you apply the negative to the -3, it makes a positive 3. So actually you can write your final answer like this, which is even nicer: 3 minus x over x. This is the final answer. Okay, next question. Okay, probability. So, the most important part that you need to read here is keeps it. If Lucy keeps it, then next time round there'll be one less bead. Work out the probability that each take a yellow bead. So with that drawing the tree diagram, it's yellow followed by yellow. So it's 2 over 12 multiplied by, next time there's only going to be one yellow, one left, and then obviously there's only 11 in the bag. Times this together, you end up with 1 over 66. Okay, and the next one. Work out the probability that these beads are not the same colour. So not the same colour, well, I can work out the answer to the question, but I don't want to. I want to work out that they are the same colour. The reason why is so much easier. I've already done some of the work in part A, yellow, yellow. All I need to do now is work out the other two, which are red, red, and green, green. Okay, so red, red would be 7 over 12 times 6 over 11. And then green, green is 3 over 12 times 2 over 11. Okay, so without using the calculator here, when you times fractions, you multiply the numerators and multiply the denominators. So I'm not using the calculator to simplify here. I did in part A, but not in this one. Okay. Now, if I add the three fractions together, I can work out the probability that the two counters are the same colour. So we've got part A's answer, that's yellow, yellow, and the other choices are red, red, 42 over 132. And the other option is green, green, that's 6 over 132. Okay. Now, if I can add all of these together in the calculator. So 1 over 66 plus 42 over 132 plus 6 over 132. Okay, and this gives us an answer of 25 over 66. Now you must not write this on the answer line, because I've actually worked out the complete opposite to what they asked me to work out. They asked me to work out they're not the same colour, and I've worked out that they are the same colour. But you see, these events are mutually exclusive. They cannot happen at the same time. You can't choose two counters that are the same colour and choose two counters that are different colours at the same time. It's impossible. So what that means is the difference between 66 and 25 must be the numerator for the probability that they are not the same colour. So we subtract from 1, take away 25 over 66. We can just work out the difference of 66 and 25, which is 41. Either way, you end up with a final answer of 41 over 66. Okay, so for this next question, we need to work out an expression for k in terms of r. Now, the key information is here. The total surface area of the cylinder is k pi centimeters squared. It mentions total surface area rather than just the curved surface area. So what we need to do is think about a net of a cylinder. So if we have a look at a net of a cylinder, it looks like this. I'm just going to use this for reference because, as you can see, there are two circles at either end, and you have the curved bit which forms into a rectangle. On the formula sheet, they give you the formula for the curved surface area of a cylinder, which is 2 pi r h, and the area of a circle is pi r squared. So there's a circle at either end. It is a solid cylinder, so we do include both circles and we include the curved surface area. So the total surface area of the cylinder is in fact pi r squared twice, which is 2 pi r squared, plus the curved surface area, which is 2 pi r h. They tell us this is equal to k pi. So we set this equal to k pi. Now, this assumes that the radius of the cylinder is r and the height of the cylinder is h. But we need to check this to see if it matches. The radius of the cylinder is indeed r, but the height of the cylinder is 2r, so I need to change that. So we have 2 pi r squared plus 2 pi r times h, which is 2r. This is all equal to k pi. Now we can simplify this a little bit. So we end up with 2 pi r squared plus 4 pi r squared equals k pi. So on the left hand side, because they're like terms, you can add these together. 6 pi r squared equals k pi. And now we can compare. the coefficient of k, we can divide both sides by pi. The pi's cancel. And we're left with 6r squared is equal to k, which is the answer to the question. Next part, show that the ratio of the total surface area of the cylinder to the total surface area of the sphere is the same as the ratio of the volume of the cylinder to the volume of the sphere. Okay, so we've just worked out the total surface area of the cylinder is 6 pi r squared. From the formula sheet, the total surface area of a sphere is 4 pi r squared. Now just check, is the radius of the sphere r? Yes, it is. So that's okay. We can leave it like this. And if you divide both sides by pi r squared, then it will cancel down to 6 to 4. And this obviously cancels down to 3 to 2. Okay. Now what I need to do is show that this is the same as the ratio of the volume of the cylinder to the volume of the sphere. So the volume of a cylinder is pi r squared h. Pi r squared h. But I know that h is 2r. The volume of a sphere is 4/3 pi r cubed. And I know that r is r. So what can I do here? Well, let's just rewrite this. So I have 2 pi r cubed to 4/3 pi r cubed. Now if I divide both sides by pi r cubed, I end up with 2 to 4/3. Yep. Now this looks quite messy. I need to show that it's the same as 3 to 2. What I can do here is, because I have a fraction which is a divide by 3, and I can multiply both sides by 3. And if I do that, I end up with 6 to 4, and then which cancels down to 3 to 2. And they're the same, which I expected all along. Next question. Rationalizing the denominator. So you need to multiply the numerator and the denominator by the conjugate of the denominator. The conjugate is the same denominator with the opposite sign. So we have root 8 over root 8 minus 2. And you're going to get your first mark for doing something like this. Okay. Without going any further, you've now gained a mark. So what I now need to do is multiply. Okay. So let's multiply on the top. Root 8 times root 8 is 8. And then I have plus 2 root 8. Root 8 times 2 is 2 root 8. Now the denominator is actually the difference of 2 squares. So you can multiply all 4 together, but we know that 2 of them will cancel. Sometimes I just like to write the outer ones. So root 8 times root 8 is 8. Then you have plus 2 root 8. Then the middle one is minus 2 root 8, which I know is going to cancel, but I'll write it anyway, just for fun. Minus 2 times plus 2 is negative 4. So these two terms cancel, and you're left with 8 plus 2 root 8 over 4. Now, I have to show my working clearly. It's very dangerous on this question to use the calculator, because you're in danger of not showing your working clearly. With a surds question, they require you to show every detail. So root 8 can be simplified, and I'm just going to do that at the side here. I know that root 8 can be written as root 4 times root 2. 4 times 2 makes 8. And then root 4 root 2 is 2 root 2. So you see, I can change to root 8 according to this, because it's 2 times the square root of 8. But the square root of 8 is 2 root 2. So it's 2 times 2 root 2, which is actually 4 root 2. So I've just shown that aside here. I can rewrite this now. It's 8 plus 4 root 2 over 4. And on the top, I can factorize a 4 out. So we've got 4 brackets 2 plus root 2. And now I can cancel a 4 with a 4, and it leaves me with the answer 2 plus root 2, which is in the correct format, you see, n plus root n. Now what you can do with these questions, not always, but sometimes you can, is you can, let's just open the calculator, you can type in the original question and it should give you the answer. So you don't get any marks for this, but you can check that you've got it right. So if I type in root 8 over root 8 minus 2, press equals, you can see that this is the answer, 2 plus root 2. Okay. Next question. So first things to spot, there's a tangent involved in this question. And if there's a tangent involved in a circle theorem question, it could be one of 3 rules, which is tangent meets a radius at 90 degrees. It's not going to be that one because there's no radius marked on the diagram. 2 tangents from an external point that touch the circle are equal in length. It's not going to be that one either because there's only 1 tangent marked on the diagram. And the other one is the alternate segment theorem. And the way that the alternate segment theorem works is you look at the angle between the tangent and the chord, and it's equal to the angle in the alternate segment. So let's take a look at this diagram and see what we're trying to work out and how we can use the alternate segment. No doubt it will be used. Another thing to spot is there are parallel lines here, so we're looking for alternate or corresponding angles as well, the Z or F shape. So what do we know? Well, we know that if angle ABE is 73 degrees, then so is this one, because of alternate angles. The one that I'm trying to work out, by the way, is DCE, which is over here. Let's just mark that on. Okay, so let's write down some facts. DEB is 73 degrees, and the reason why is alternate angles are equal. Now, what else can we do? Well, I mentioned the alternate segment theorem earlier on, and we can certainly use the alternate segment theorem to help us here. Because if you take a look at the line AB, that's a tangent. And there's also a chord in the circle, which is EB. If I just use my highlighter to show you this. So we have a tangent here, and we have a chord, and the chord is EB. Now the angle made between the tangent and the chord is equal to the angle on the alternate segment. And what you do in theory is you take your chord and follow it to the edge. But as you can see, there is if you look at the green line, there's a chord coming off it at E, but there's no chord coming off it at B. So you need to draw an extra line on the diagram. And if we draw an extra line on the diagram, it will make things a lot straightforward. So if I draw an extra line there and look at the green line now, if you follow the green line to either side of the circle, the green line leads to D. And that means the angle there, so if you follow the green line to the edge like this, the angle made over here will be the same as 73, and that's the alternate segment theorem. So now we know that BDE is 73 because of the alternate segment theorem. We also know now that this angle here will be 34 because angles in a triangle add up to make 180 degrees. So now we know, write that down, that's DBE. So DBE is 34 degrees. And finally, the angle that we're interested in is this one here, DCE. Now, if you take a look at the chord DE, yeah, so just focus on the chord DE. The chord DE leads to this angle here at DCE. So if you take the purple chord there, DE, and follow it to the edge, yeah, it works out that angle DCE. But if you take the same chord, I'll use a different color this time, blue. If you take the purple chord and follow it to somewhere else on the circumference, so like you follow it to this angle here, DBE, then you can see quite clearly that because they are angles from the same chord, they're equal, you see. So this is also 34. And that's called angles in the same segment are equal. So it's DCE. It normally looks like a bow. Maybe you should turn the page around and you can see. So DCE equals 34, and its angles in the same segment are equal. Okay, and that's the answer to the question 34. Next, this one. So find the size of the angle between the line MA and the plane ABCD. And more often than not, these questions can be answered very nicely using right-angled triangles and trigonometry and Pythagoras. So this question seems a little bit different because there's no measurements given, but that's fine because it's a cube, you see. So if you want to create some measurements, then it doesn't matter. We could all choose different numbers as long as it's a cube. So if it's a cube, all the sides are the same on a cube, and we'll all get the same answer. So what I'm going to do, because there's a midpoint on this, I'm going to choose for the cube to have side length of 2. So all the sides are length 2. Okay, and that means this bit will be length 1 and this bit will be length 1 because M is the midpoint. Now what I'm looking for is the angle that's made between the line MA, which is here, and the plane ABCD. So if we shade the plane, yep. So it's this plane here. Now you can only work out the angle between a line and another line. So we need to put a line on the plane, but it needs to form a right-angled triangle. So we know that one of the lines is AM. We can draw another line connecting M down vertically like this, and then back to A again. And that forms a wonderful right-angled triangle there. Now, if we draw the right-angled triangle separately from the diagram so we can see what's going on, I'll just mark the letters here. This is M, but let's call this point X so you can see where it is, X, and this is A. Now, MX is vertical, and AX is a line that lies on the horizontal plane. So if you have a line that lies on the horizontal plane against a vertical, it forms a 90-degree angle. So it may not look like it from the diagram, but if one is horizontal and the other is vertical, it does indeed form a right angle between them. So this is MX's length 2, and I'm trying to work out this angle here. I need one other side, either AX or AM. So you can work out ax by using Pythagoras on the base, but I always like to work out am, the diagonal, and there is a formula to work out the diagonal of a cuboid. It's Pythagoras in 3D, which is a squared plus b squared plus c squared equals d squared, where d is the diagonal. So in this case, am is the diagonal. A, b, and c are the length, width, and height of the cuboid. But you've got to imagine that because we're not going from A to H, A, B, and C are not 2, 2, and 2. They would be 2, 2, and 2 if the diagonal was AH, but the diagonal is AM. So you can see it's 2 by 2 by 1. So I can do something like this, and it doesn't matter about the order, of course. So it's 2 squared plus 2 squared plus 1 squared is equal to d squared. And if you work this out, d squared is 9, so that means d is 3. So this side is 3. Now I have the hypotenuse here, and I have the opposite. So I'm going to use sine. So I have sine of the angle. Let's call this y. Sine y is equal to opposite over hypotenuse. And then y is equal to the inverse sine of 2/3, which is 41.81, etc. And when you round it, it's 41.8 to one decimal place. Next question. This is sine or cosine rule because we have a non-right angle triangle and we're at the end of the paper. So what do we know? Well, we need to ask ourselves this question to do with the sine and cosine rule, non-right angle triangles. Do we know a side and its opposite angle? If the answer is yes, then we use the sine rule. And if the answer is no, we use the cosine rule. So, do we know a side and its opposite angle? The answer is no, because this is x. It tells us that x is y minus 1, and the other side is y. So if I change x to y minus 1, then at least this question is all in terms of y. So do we know a side and its opposite angle? The answer is no. So what are we going to do? We're going to use the cosine rule. The cosine rule we can copy down from the formula sheet. It's a squared equals b squared plus c squared minus 2bc cos capital A. B and C are the sides that sandwich the angle. So B and C are either side of the angle. It doesn't matter which way around, C or B or B or C, but they are either side of the angle. Now we can start to substitute into the formula. So we have something like this. Y minus 1 squared is equal to 5 squared plus y squared minus 2 times 5 times y times cos of 60. Now you must not square this bracket by squaring the y and squaring the negative 1. That's illegal. What you need to do is write out the bracket twice and then expand it. So either you do this at the side or you can do it as part of your working, but you write y minus 1 times y minus 1 and try to expand it. When you do that and simplify, you will end up with something like this. Y squared minus 2y plus 1. So just from above, 25 plus y squared. Now let's have a look at this one. I want to know what cos 60 is. So just type in the calculator. Cos 60 is the same as a half. So this is a half. Just put a line through that. Now I know it's a half. So what I need to do is 2 times 5 times y times a half. Okay. 2 times 5 is 10. 10 times y is 10y. And then half of 10y is 5y. So we have minus 5y here. Now, we have a y squared on both sides. If you take away y squared from both sides, it's going to cancel. And what are you left with? Well, we're going to rearrange this, okay? What I'll do is I'll collect all my y's on the left. on all my numbers on the right hand side. So I end up with something like this: 5y minus 2y is equal to 25 minus 1. So 3y is 24, which means 1y is 8. The question says to work out the value of k. K is the perimeter of the triangle. So now we know that y is 8. This side is 8, of course. This side is y minus 1, so it's 7. This side is obviously just 5. Add the 3 together to work out the perimeter, as perimeter is the distance around the edge. You end up with 20. So a vectors question here, which maybe it's been found to be a bit difficult according to the examiner's report. But I think drawing some additional lines on will help with this question. And the key thing that you need to remember about vectors is they have direction and magnitude. Okay, and these are the only two things that you really need to remember about vectors. So just to glance at the diagram, vector AB is A, so we can label that with an arrowhead. This is A, and vector BC is B. So drawing an arrow going from B to C. Now, what you must not assume is that vector BC is the same as vector AF, because they look like they're the same length. That's not true, because as you can clearly see, it does not have the same direction. Now, what I'm going to do here is I'm going to show you using colour on here. So let's just draw over that. In fact, let's make that a bit thicker. And this one as well. What I want to do is I want to find lines on the diagram that are exactly the same as vector AB. And you can see there's one down here. There's quite a few on the diagram actually. What I'm going to do is I'm going to draw some additional lines on to help with this question. So let's draw some additional lines on this. Remember, this is a regular hexagon. So if we draw some additional lines on, it will help quite a bit. Now, what I'm going to do, so just use the green color. I'm going to label all the other vectors on the diagram that are vector B. So vector B, we have one here, which is exactly the same and in the same direction, and here, and here. They're all vector B. And all my other vector A's on the diagram, so there's, oops, we'll do that in red. Okay, there's one there, exactly the same direction, same magnitude, and there, and there, and there as well. Okay, so if I want to, I can label all of these A, and I can label all the green ones B as well. Just got to make sure the arrow is correct, it's in the same direction, because if you go against the arrow, of course, then it's negative. So what I'm trying to do is work out vector EX. How do you get from E to X on this diagram? So let's take a look then. Okay. It would be great, you see there's a few missing ones on here, and what I'll do is I'll draw those in another color so we can see. Let's do those in purple. So the ones that I'm marking on now, they're different from the red ones and the green ones. But it would be great if we could work out the purple vector, because then I can have a nice direct route to get from E to X. Okay then. Well, let's try and figure it out then. I want to end up, I want to work out what one of the purple lines is, okay? So how do we work it out? Well, let's just take a look at them. So let's just figure out here how to get from, let's go this way. So if we go up this purple line, yep, we can go right A, and then we can go backwards B. So it's A minus B. So that means the purple line is A minus B. And now it should be quite straightforward how to get from E to X. So E to X, vector EX is A plus A minus B plus A minus B, which is 3A minus 2b. Next. Okay, functions. So let's have a look at this. So find the value of p for which the inverse function of p is equal to k. So what I want to do first of all, I won't worry too much about the p. I can see the inverse notation. So I'm going to work out the inverse function. Okay, let's get some marks for that. So how do we work out the inverse function? Stage 1, we write it as y equals. So we have y equals x root x squared plus k squared over x. Stage 2, we interchange our x and y. So x is now equal to the square root of y squared plus k squared over y. Stage 3, you try to rearrange this to make y the subject. So let's times both sides by y. What we're going to try and do now is make y the subject. Okay. Now, as you can see, I have a y inside the square root. So I want to undo the square root. The opposite of square rooting is to square. If I square the right-hand side, then obviously the square root will disappear. But if I square the left-hand side, I square all of xy, so it becomes either xy in brackets squared or x squared y squared, which is what I prefer. Now I'm trying to remember what I'm trying to do. I'm trying to make y the subject. So I'm going to collect all the y terms on one side. So you have x squared y squared minus y squared is equal to k squared. Y squared is common, so I can factorize it here. Y squared brackets x squared minus 1 is equal to k squared. And then I can rearrange this. Y squared is equal to k squared over x squared minus 1. And that's because, of course, they're times together here, so it becomes divided on the other side. And then, finally, y is equal to the square root of this. Okay. Square root of k squared over x squared minus 1. Now, I can, the final stage, of course, is to replace the y with the inverse notation. So I can rewrite this as f minus 1 of x. Right? And that's now, I've now worked out the inverse function. What they asked me to do is to work out the inverse function, substitute p in, and then set it equal to k. So the bracket, as you can see, has a p in there. My bracket has x. So what I need to do is replace the x with p. So where I see x, I replace it with p. But what I set it equal to is k. So it's a bit like this. I'm going to set it equal to k, like this, k equals, but I'm going to change the x to p. And the question says, find the value of p for which this is true. Find the value of p. So what I need to do is just work out what p is now. Okay. So how do we do this? Well, square both sides to get rid of the square root. So you have k squared equals, and then k squared over p squared minus 1. You can do a bit of rearranging here. Okay. If you ever have a situation like this where you have a equals b over c, then you can swap c with a. That's allowed. Okay, and you can use some numbers to see why that's true. But I can swap here, you see, and I can end up with p squared minus 1 is equal to k squared over k squared. Now, anything divided by itself is 1. So this is 1. So you have p squared minus 1 equals 1. So p squared is equal to 2. And that means p is equal to plus or minus the square root of 2. There's some other information here about k and about x. K is a positive number, but also x is greater than 0. So what is p? P is an x value. We replace the x with p. So if x is greater than 0, that also means p is greater than 0. So the answer negative root 2 is invalid, and thus we write down the only answer to the question, which is root 2. Okay, next question. The function g of x is x squared for x is greater than 0, and g f of a equals k. Right. So this obviously uses the previous part. What is f of a? Well, f of x at the top of the page is stated. All I need to do is just replace the x with a. So it's the square root of a squared plus k squared over a. Now, g of this is equal to k. So when we have composite functions, this bit on the right-hand side goes into the first letter. So it's g of this, and g of this is, well, let's have a look. What does g of x tell us to do? It tells us to square the x value. But the x value, remember, is g of x, right? X is now this. All of this is my new x. So we can write down g of this is equal to k. They set it equal to k. So what do I need to do? Well, let's have a look at the left-hand side. The left-hand side tells me to do g of this. Now, the g function is x squared. So remember, what's inside this square bracket is my new x. So I replace x with this. So it's root a squared plus k squared over a, all squared, and that equals k. So when I square the brackets, you square the numerator and the denominator separately. If you square the numerator, you end up with a squared plus k squared. If you square the denominator, you get a squared, and this is equal to k. What I need to do is find an expression for a in terms of k to make it a equals. So times both sides by a squared, so you get ka squared. And remember, I'm trying to make a the subject. So let's collect all the a's on one side. Attempt to factorize, because a squared is common. So you get k minus 1. And then let's just write down here. So k squared over k minus 1 is equal to a squared. And that means a, finally, is equal to the square root of this. Now, when you square root the top, you get k. When you square root the denominator, you get k minus 1. So root k minus 1. This is the answer to the question. Thank you very much.